Hey guys, so as you've seen there, plenty more dyno runs and a lot of tuning by Alex here at Birrong Automotive. So we did change the actuator to a 16 PSI one, which bolts on with the factory turbo. We were able to then bring the boost up quite easily back to 20 PSI, but we were still having the boost tapering off, and Alex wanted to get that remedied straight away. So the guys here hooked up a Turbo Smart Mac valve to the factory wiring. He made some adjustments with the Link ECU and got that all working accordingly. So if you just take a look over here we've got manifold pressure. So now we've got, this was the blue line was before where it was tapering off. So peak, we were at 19, dropping down the deep end, we're at 16.7. Okay, so now we're holding 20 PSI, 21, 20, 20.5, 20, so basically 20.5 average all the way through now. So what we can see here over the power, through further tuning and dialing in the whole setup, he picked up a little bit more power up top here. So we went from 266 at this point to 273. Peak before was 268, now peak is 273.2. Looking back over at the boost, so why have we got more boost and not more power? Basically something's starting to increase our back pressure. So even though we're giving it more boost, the increase in back pressure totally fights that increase in power, because you're putting more pressure on the piston through the back pressure. So what we're going to do now is we're probably going to start looking at changing up the exhaust. The catback exhaust of this car is a bit restrictive, so we will be switching that to a true 3.5 inch exhaust. We'll probably fabricate something ourselves in-house just for testing purposes. One of the things the Japanese do with their exhausts to pass and get JASMA certification, which is Japanese Aftermarket Sports Muffler Association, if anyone ever's wondering what that actually means. So they have to basically pass a DB rating. They have different certification levels to adhere to in Japan for street cars. So we'll do a true 3.5 inch catback. This car already has an aftermarket 3 inch downpipe and mid pipe and high flow cat. So we know it's not the front section that's causing the main issue, it's the rear section, as the internal diameter of the rear muffler is about 63 millimeters, about 2.5 inches. So we'll get that changed first to see if we can reduce that back pressure issue and try and pick up some power. Another thing you may have seen there in the video there was putting some water on the intercooler. It's got a Blitz intercooler on it now. It's a 70 millimeter intercooler. Might be 63, I'll double check that later. The temperature was steadily rising all the way through the power run. It's okay for testing like we're doing now, but if they're out of control now, and I mean by out of control as in it's not holding a fixed temperature, it's just constantly increasing, it means that when we start doing circuit testing, where you're on the throttle a lot more, we may be running into further temperature issues. So after we do the exhaust, we will be looking at changing the intercooler. We'll probably call on the guys at Plasma Man and see if we can get a 100 millimeter, maybe an R34 GTR cooler, and have it fitted up and plumb that up as well. Really happy with the progress. We've got boost control now locked in. We were going to do camshafts after this mod, but we can clearly see that back pressure is becoming an issue. So doing camshafts is kind of counterproductive. There's no point putting more air into the motor if it's not getting it out properly. All right, so here we have the new Mac valve. So this has actually had a Deutsch plug put on it from the guys here. Chris worked his magic with the factory wiring. So that's now running the boost control through the ECU. We did do some testing of removing the airflow meter and air filter to measure if there's any sort of restriction that was being occurred at this power level. There was none. There was no gains at all. There is other information that can be happening with turbine speed, but overall it wasn't affecting our power in any way. So for now it'll remain until we do find that limit where it does become a restriction. So guys, thanks very much for tuning into this episode, and we'll see you next time with the new exhaust done. Alright guys, so Alex has just finished up tuning the car, absolutely wrapped with the results. So normally with modifications with cars, there's some sort of trade-off. If you put something in and it makes more power at peak RPM, you lose it down low, or vice versa. You pick up down low, you lose up top. I.e. turbine housing sizing, you might gain it up top if you put a big one on, but lose it down low, or vice versa. So somehow we've put the Kelford 264 inlet and exhaust cam in the RB25 Neo, as well as their valve springs. Whilst we did that, we also put in some ARP 2000 head studs, and we've picked up power at both ends of the rev range. Down low, when we're engaging the dyno, just shortly after, we're picking up 8% more torque down low. And then all the way through, here we can have a look at the graph here. So here's boost pressure, so it's actually responding quicker. We're actually making more boost down low, which is what would be probably giving the extra torque. And then you start seeing the power, the previous runs on low boost. So we're on about 16, where are we? We're on 14 PSI here. Matched it dead on. Thanks Link ECU for the great boost control. So here we go, we're following it down through the rev range. From here on we start gaining. So we've matched it all through the mid-range. We picked up more down low, and up top we start walking away, and we picked up 25 kilowatts up top, and we can also rev it. We're also revving the car about 600 RPM further in the rev range now. So yeah, really happy with that. We think we're definitely at the limit of this turbine housing, turbine wheel. It's actually just a fairly small bolt-on turbo. As you can see, the power delivery is phenomenal now. So yeah, really happy with that. We did try the high boost pressures again, like we did before, but again the back pressure just went through the roof and it was sort of dying. So on low boost on 13 PSI down here at the moment, yeah, we picked up 25 kilowatt. To sum it up, down low in the rev range, we picked up 8% power down low. Torque, sorry, 8% torque down low. You can see here, power wise, roughly 9% down low, and then up top we picked up 12% power right up in the rev range. So yeah, very happy with that, considering no losses. So yeah, great mod. And if you're going to be swapping cams or you want more power up top, yeah, I'd highly recommend switching to some Kelford 264s. If you want more power up top, of course you can go the bigger camshaft, but for us this is a street car. We're trying to keep the power ranges as large as possible, and again, great gains down low. What's next? We are going to do a larger front mount intercooler. Again, going, as mentioned before, we had the Blitz 70mm. We are going to go to a Plasma Man 4-inch or 100mm cooler, and we are going to switch to a Plasma Man top half intake manifold. So that will help us reduce the intercooler piping, and so I'm looking forward to seeing what that actually nets us on the dyno. We will be continuing our testing on the lower boost pressures, just so we don't run to back pressure problems that we've currently got. Later we will be changing the turbo, but until then we'll just keep on the lower boost pressures. So thanks very much, and we'll see you next episode.